and then we have to recalculate for.
Yeah, you can, and it is obvious, you know the 1000 ppm sulfur, having this correlation of the sulfur. Suppose you are not having the, you will get the lecture, no problem. Strong.
Then why you are giving us?
Strong. You can try it. I have the value of RI, I have the
But
value
before
additive for high pressure lubricant, diesel fuel ignition quality improver, CT number improver, cutting oil improver, detergents and asphalt improver. See some of the compounds I have given over here. ZNDP, zinc diethyl dithiophosphate, used as antioxidants in lubricating oil. Additive for high pressure lubricant, thioethers, alkyl disulfides, aryl thiosides, anti-xanthic disulfides, used additive for high pressure lubricant, anti-static additives, 1-decene polysulfone. How to remove this H2S? Sodium hydroxide, it will give you the PBO. Correct?
Yes.
It will give you PBO. For making this doctor solution, you take the lead tetraacetate, 60 gram, dissolve in 200 gram of the sodium hydroxide, make it to the 1 liter, keep it for a whole night, then decant the solution. That is your doctor solution. Doctor solution. This will give you CS3COONA plus PBO plus H2O. Correct? Now, this PBO will react with your mercury H2S. It will form the PBS plus H2O. It's a brown precipitate. It will reduce your sulfur content. This is doctor solution. Doctor test is a qualitative test. Just you take the 5 ml of the doctor solution, 10 ml of your fuel.
So doctor solution is the chemical only, the chemical.
Yeah, chemical. Lead tetraacetate. For making the doctor solution, you have to take the lead tetraacetate and sodium hydroxide. Lead tetraacetate brown ring at the junction, because one is your aqueous layer and one is hydrocarbon. Brown ring at the junction, that is a qualitative test to presence of the hydrogen sulfide in your fuel. This one reaction, PBO H2S, this is doctor solution.
Yeah.
And this is H2S. You are getting the lead sulfide, you are getting the water. And of the sweetening process also. And I will still आगे मुझे बढ़ने तो देते नहीं हैं. Non-corrosive in nature by the sodium combined. That is Na2PbO2. Form PVS plus 2NaOH. Correct? This is brown precipitate. NaPbO2. This is doctor solution. Same will react with the mercaptan. Na2PbO2 plus RSH. It will form you PB whole PBRS whole twice plus 2NaOH. PBRS whole twice is lead mercaptide.
So it will also precipitate.
Just PBRS whole twice is lead mercaptide. Correct? But this is not brown.
But it will also
So
precipitate.
mercaptan will not give you the brown test doctor solution. Now what you do, you take this test tube where the mercaptan is not, the brown ring is not coming, you add a pinch of sulfur from outside and again shake, you will get the brown ring. How? Now lead mercaptide, it will react your pinch of sulfur, it will give you PBRS plus RSSR. Now this is doctor sweetening, chloride sweetening, and correct? Now this is all about the sulfur. Now we come to the nitrogen. Nitrogen is present in the crude oil in the form fuel property, but for customer satisfaction, you cannot sell it. Correct? Nitrogen is a toxic because emissions of nitrogen is coming in the form of the NOx, oxides of nitrogen. So they are toxic. They are one very good correlation is to percentage of nitrogen over percentage of C. Total carbon, when you are having the CHN analysis, then percentage of nitrogen upon percentage of C is being used for finding out the comparative younger or older oil type. You are having the two samples, one young well, another same, one well is here, one well is here. You are taking the two. You want to know which one is the older, which one is the young. So the higher the ratio of the percentage of nitrogen to percent C, younger the crude. Because you see, poison for catalyst, like your hydrocracking, all these you are using the zeolites as a catalyst. They are having the acid sites, active acid sites. Poison to the catalyst, temporary phenomena, compounds in for deterioration in the color and also degradation in the catalyst. Nitrogen compound increasing the boiling point, nitrogen increasing and decreasing because lower to higher fraction, increasing the density, concentration of nitrogen increasing. Lower in naphtha, higher in residues. High value of percentage of N and C, percentage of N and C are predominating in geologically young crudes, and this ratio appears to correlate crudes of the same geological age in certain geographical areas. Now we come to the oxygen compounds. Oxygen is present in the form of the naphthenic acids. They are present in the form of phenols. They are found in the asphaltene, the synthetic atom between polycyclic. Most dangerous is your naphthenic acids, which can be removed by crude oil treated with the sodium hydroxide. You will get the sodium salts of naphthenic acid. That naphthenic acid regeneration and purification will give you the metallic soap used as varnish tire, manganese and cobalt naphthenase as varnish tire, copper naphthenase as fungicides and good preservative, calcium and zinc naphthenates as lubricating oil dispersing additives, aluminium soap gelling agent as napalm. Means if your total acid number is high, correct?
Yeah.
You give a treatment with the sodium hydroxide. Sodium hydroxide will neutralize your acid. It will form the sodium naphthenates because naphthenic acid plus sodium hydroxide give you sodium naphthenate. Sodium naphthenate will settle, you regenerate it, and then sodium, you react the naphthenate, sodium naphthenate with certain metals like vanadium, copper, aluminium, and you can use as giving. Like with copper, fungicides and preservative, with magnesium, cobalt, varnish dye, for calcium and zinc, dispersing additive, aluminum soup, gelling inhalers, napalm. Clear? So this is oxygen, and this naphthenic acid creates the problem in the corrosion of the distillation unit. Corrosive in nature, corrode distillation unit, it forms the peroxide, it forms the naphthenic acid. Now, high molecular weight nitrogen compounds and sulfur, they compounds present in crude oil, in asphaltene molecules, molecular weight 30,000 to 3,000 to 10,000 is the resin. This is the composition of the asphaltene, where it contains the micelles and particle. Resins possesses lower molecular, the combination of the micelles, particles and resins. Somebody was asking yesterday what about the asphaltene or bitumen. The bitumen contains the asphaltene, and that asphaltene is the micelles, contains micelles, molecular weight 30,000, particle up to 3,000, 10,000, and resins from 500 to 1,200, and molecules probably consist of sheet comprising of 10 to 20 caloric sheets. Now, asphaltenes, you can read it, otherwise you will delay my lecture. And then lastly we come to the metallic derivatives, metal found in the ash of petroleum residue. Petroleum residue as petroleum fraction, associated brines which is emulsified with or has such contact with crude, salts and organic acid present in the crude oil, particularly in nickel, vanadium, copper. Metallic concentration in crude is very often less than 1% is found up to the 1400 ppm limit. Zinc, titanium, calcium, magnesium appear in the form of organic metallic source with surface active properties absorbed in the water oil interface acting as emulsion stabilizers. Vanadium and nickel occur as very stable oil soluble nitrogen complexes in the form of profiles. This is all about the chemical. Today at 12:36, morning of 11 o'clock, only one lecture is complete. But can I do?
Excuse me. Is there any way that we can remove the vanadium and nickel?
Vanadium nickel, the metal removal is very difficult from the metals removal, because these metals you are seeing here, but they are present in the form of the porphyrins, and they are the central nucleus of the porphyrins. This is the porphyrin structure. How can you break? Might be copper, might be nickel. These are the from 21 to 38 are being used for sweetening process. What they do? These structures catches the sulfur. Metals is there. This metal will catch the sulfur because of the variable balancing compounds of the sulfur. So you sweep only things the natural gas and what is the difference, what is the source of the LPG, how the LPG is detected.
You bring I give you can read.
Yeah, right range.
That is not in my sugar. I said something. My sugar like this. That is my sugar. But he say my sugar. I don't know. My sugar here. Yeah, that's sugar. That. And number 2 and connect and It's nitrogen. Nitrogen here. Different.
Rajneesh, there is specification collector, cool it and then take it weight. So the difference is say it is coming foundation, tobacco and rice breeding, tractor operation and irrigation pumping. The tobacco which is present in the cigarette is the roasted, it's not as it is obtained from the tobacco plant. So therefore, roasting for tobacco and rice breeding, you need this for tractor operation and for irrigation pumping. This is some of the specification. Now corrosion, liquid volume maximum 2, ethane 95%, butane 4%, and pentane maximum 3. This is the propane is 95%, ethane 2%. Propane 95, butane 4%, pentanes and heavier nil, total olive is 1, corrosive compounds copper not more than 1B, that is a rating, hydrogen sulfide maximum 5, specific gravity not reported, to be reported, maximum sulfur 30 ppm, and this is the vapor pressure at 100 degree Fahrenheit, PSI maximum 200, and then kilo PSI is 1380, and water content maximum 10 ppm per metric ton.
This LPG will
I will show you the specification. This is specification of LPG. This is IS 45761999.
IS means Indian standard.
So,
19 IS is butane dominated, butane dominated, or 50-50 butane value. So accordingly, for propane, minimum 95%, maybe 96. That is minimum, but this is the maximum limit is of C4 is 4, but butane is it passed the doctor test. Now at 40 degrees C kilopascal, method ISO 4256, pentane hydrocarbon, because LPG contains some of the heavier fraction that comes as the residue. There is a C5 which is in the car. So you reduce it. So the copper is corrosion 1, 3. So this is IS 4861. They don't worry about the propane, butane, and anything. Their vehicle should run. By volume in the air can burn. So this is the LEL. Now you see the automotive purpose, same is continued. IS 14861. You see the research octane number for propane 112, motor octane number 105, and butane 9592. Isobutane 100.4, 99, propylene 100.2, motor octane number 85, and butane 180, and butane 2 101 and 83, regular motor gasoline 92 to 95, and motor octane 83 to 86. You know what is the motor octane number and what is the difference between motor octane number and such octane number? Low octane number. Here you see the butane 2, butane 1, and these are the orifice. Now we come to the vapor pressure. Vapor pressure affects the engine start ability at low temperature, control pressure variation, creates dispensing problem, depend upon the composition of the LPG. The vapor pressure.
Yeah.
That depends on the propane and butane mixture.
And we have the other product is rubber block.
Like you shine it with the embry paper, size is standard, and then dip that copper strip with the fuel and at desired temperature. It is always specified with the copper strip corrosion Either it is being done at 50 degrees C, 100 degrees C, or 40 degrees C, or 38 degrees C, and for a certain period. Because when you are reporting the copper strip, you have to mention 50 degrees C means temperature, degrees C, 2 hours. And after that hour, you take out the strip, you dip the strip in the isooctane, as is because if you are using the diesel or kerosene, anything, so oil might be C6 is there, but that creates the problem in the engine when you are using in the automotive fuel. Heavier hydrocarbon forms the residue.
Because the only source is mainly presence of C5.
Yeah.
Contamination can be the source.
This is the source. From source.
Okay, so it is from source.
You cannot do the ventilation. Now we come to the weathering test. Weathering test is also for LPG. Test is an indicator of debutanizer LPG naphtha separation. 95 ml out of 100 ml separated must evaporate to 2 degrees C. Leaving 5 ml only unevaporated, the amount of liquid remaining unevaporated at 2 degrees C is the amount its C5 material present in LPG. If C5, you are asking that why the residue, this is weathering test which detect the C5. That is undesirable, clearly undesirable. LPG tester covers the determination of extraneous material weathering above 38 degrees C that are present in the liquefied petroleum gases. The extraneous material will generally be dissolved in the weathering test of LPG.